it seems we are live, and continuing on with the PCB layout of my motor drive design, which has been documented here on YouTube in a bunch of videos from the beginning and until now. And the idea is that I'm going to be documenting this project up to the point where I'm actually going to be testing it. So it's going to be a fun series. So subscribe to my channel and you'll be notified whenever I send whenever I broadcast live on YouTube. And let's take it from here. So I've laid out many of the peripheral circuitries of the board. And I like to start from the outside and then move in, because the connections to the main microcontroller may need to be changed. And that would depend mainly on how things are connected and which pins would cross. So for example, we see here we have the current sensing, and this is analog traces. So crossing them is not a very good idea. I would have to actually create a via on one of them and then cross them to connect them to the microcontroller here. So this is a typical case where it would be better to just swap them around, because it doesn't make much difference from the software side. It's just a matter of reassigning the pins. So it's very good to solve this during the routing stage. And if you can tell me any auto router that can do this, then I'm very surprised, because I haven't seen one. And the thing is that we cannot actually know ahead of time how things are going to be placed. So we can't make these decisions during the schematic design. We can place components and maybe even route some of the peripheral circuitry here to know this pair of pins being swapped around. And just to make sure here, so we have that one there and that one there. And it would be also a good idea to swap, if we could somehow wire them so that we don't have to create a via either. So it goes to the first one. So in this case it works really well. In this case we have the first one, and so they will just go directly there, and from there on they will go to the microcontroller there. But with this one, let's see, with they're actually going the other way around. So we could actually wire it from the inner side here, and then out, so that we actually swap the traces, and that will ensure that we don't have to cross any traces here. So let's swap around. Let's see, we have this one is there, and I'm going to swap them on the microcontroller side, so I can just click on the pin. Let me click on the pin, and I should get the cursor. There. So there is the first one, SOB2, and the SOA2 is the other one that we need. So SOA2 is actually over there. So this one will be SOB2, and this one will be SOA2. And actually I'm also going to have to move the resistors here so that I can just drag this trace straight to the pin. Alright, so I got those two untangled, and I'm not going to route them just yet, because I want to untangle anything else that I can untangle here. Let's see, we have a few things here actually, like this one. So this one goes to the GPIO there. Now let's see if there's anything we could sort of rewire here. If we have a look at the pins that are 140, I think that's PD, GPID, and we have the enable, we have the chip selects. So this one, no, because I want them to be directly connected to the yeah, actually anything that goes to this side of the board. There isn't that many things that right, maybe I could use this these two pins to control something here. Let's see. I guess that would be just some kind of interrupt, maybe. Although that shouldn't go either to the SPI GPIO. What could we remap here? Or maybe something on the second motor controller. Okay, I guess I'll just have to go through the pins and just see which ones are suitable for mapping to an SPI GPIO. So no, 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 no. This one maybe 140. That could be one. The Writeprotect on the EPROM, that doesn't have to be on the microcontroller directly. 140 is somewhere here. Maybe I could click on it actually. Let's see. No? I can't click on the pin. Oh, actually, damn it. I have to be... Yeah, pin 140. There we go. So this one is... Yeah, this would be actually very suitable for a connection here, if we could remap it. But we need another one still. We need to... Let's just double check also. And this one goes there, okay. Yeah, this is doable. This is good. So we need to find another one as well. Is there another one that we can just remap? Okay, I'm gonna drag this one out for now, and then we have write enable for the this one is on the pin 69. No, no. Definitely no. Okay, no, no. Actually, anything on this side is probably, might as well just skip anything on that side. So I checked through the 100, let's see, so 133 to 140. So I checked these ones, and then we have 137. I think it's probably this GPIO here. Yeah, let's check this one. So GPIO reset. I think that one goes to, or actually that's 56, so that's probably not suitable either. Yeah. So let's start with 124. No, 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 or actually, let's see. Let's see, where does this connect? No. If I were to remap that one, I would have two layers of like interrupts. So first the interrupt will arrive at the SPI chip, and then that would generate an interrupt, and then I'll have to read the SPI chip to see which interrupt occurred here. So no, too many layers. Better to have it directly connected to the microcontroller. And then we have no, and then is there anything else here? 100 and yeah, I guess it's only this ones. So no, no, N gate, no, 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 no. Overcurrent, is that overcurrent mode or is that overcurrent, the actual overcurrent? Let's see. No, that's not going to go there. This one would actually benefit from being remapped somewhere here. Okay. And all of these probably, yeah, probably no. So I guess that's out of the question actually. So this would remain there, and I'll just have to route these two pins there, or just remove that completely, that functionality. Let's see. So I have Writeprotect and Reset. The question is, like in this case it's not really needed. I can understand that it would be a very good idea to have Writeprotect on the overcurrent protection, but this is kind of like a primitive analog joystick output, so this would be written all the time. So Writeprotect is not actually necessary, and the question is if Reset is necessary on this one, or if we can just I'm going to open up the datasheet of this chip, and I'll check what Reset actually does. Like, does it reset the I2C interface? In that case, it could be useful. Or is it only for resetting to like default values? Come on. So this one has a reset. Reset input pin. Reset. Let's see. Reset has a pull-up of 16K. So can it be okay? Power on reset. Power on reset in this case is the case where the device is having power applied to it from say brown out reset occurs. Yeah, ROM retains voltage, retention voltage lower than. Okay, this feature allows a hardware method for all registers to be updated at the same time. So it sounds like it's useful. This is definitely not something I'm going to remove. So if I remove actually this one, then I could have the Writeprotect. Right. So this one is active low. So I'm just going to double check this. So what do they mean by disabled? Do they mean that it has to be low? Status, let's see. I'm pretty sure it's low. I just want to double check it. Pretty sure it's active low. And what does smart pull-up mean? Let's see. The question is, do we need a pull-up on it, or can we have internal pull-up? Pin smart pull-up shuts off while the pin is forced low. Okay. I see. So Writeprotect can be, I think, according to the datasheet, can be left floating. And then we have this pin here, where we can remove that label. And AP reset will go up here. And this one will go there. It's going to be very nice to get rid of this really long pair of traces. Let's see, we have AP reset 1. I think. Oh, I think we only have one. Yeah, there is no AP reset 2, because I had an original idea to have 2 of them, but then I just used one. So reset 2 is not present. Yeah. Okay. Cool. So update PCB from schematic, and I should have gotten rid of this. Let's see. There we go. And then that one goes to the microcontroller, so it doesn't have to cross over the whole PCB here. And I still have the I2C that goes, let's see. Yeah, this is a bit of a unfortunate, actually, that I have I2C going like that across the board. I would have really liked to avoid that. Could I perhaps use a different I2C bus? Let's see. Maybe I can rearrange things a little bit more here. Nah, it seems to be like the only option. I'm using 2 SPI buses, but then only one I2C bus where everything is connected. So it's kind of unfortunate actually that has to go across the board. Yeah. That's 4 and that's 14 centimeters. It's quite long. So what we have here is these ones are not critical, but this one is critical. So this is a bit unfortunate. Maybe I should move this to the UX. I think that would be a better solution actually. This one is responsible for the overcurrent set point. It's kind of more critical. But then on the other hand also, once the values have been set and the chip has been write protected, because here we have the Writeprotect pin connected, then this value will not change until like reload of configuration. So on the other hand, it's kind of, even though this is critical, this can be protected so that even if the I2C bus hangs, this will not be affected. Or rather this will not sort of suddenly trigger the overcurrent fault and inadvertently stop the motor. So this is not really an issue, I think. Got the Writeprotect here. Goes to this SPI interface. And the LEDs, they're not important either. They're not critical. Let's see, I can rotate this one. It's better. It's a little bit better placement of this chip. And then we have the I2C going there, and continuing on here. Okay. The LED, the LCD display, also non-critical, can be placed there. And then we have these ones. So this is going to be the SPI bus that connects to a whole bunch of devices here. So it's GPIO, it's the encoders, and yeah, it's basically the GPIOs, both of the GPIOs, and then the encoder chips. So these two. That's going to be connected to the same SPI bus. A whole bunch of let's see, intersections there. This is the temperature sensor. So maybe, let's see, so we have another temperature sensor here. which connects where? Which connects here, and that goes there. Yeah, that's a bit unfortunate. I think that this one should really be here. Okay, so hiding the footprints on the top layer, I think these ones can be routed actually, except for things like this. So let's see, I'm gonna move this out here, and this spine as well. Like that. And this one will have its own wire to the. So I'm gonna change the track width a little bit. And we can just route all of these. This one is, yeah, right. So let's just do it like this, and then a wire there, and then this is the pull-up, I think. So it can essentially go. There. And then, nope, back there, this one goes there, and this one, okay, let's see. I think this one would be better off at the. Let's see. So essentially, this one should go around there, but the Keycut router is not very smart, so it creates this kind of crap. So yeah, let's do it like this instead. So I'll just move this one a little bit. I could have it automatically shove the other traces as I route, but I don't want to have that functionality enabled because then it will mess up traces that I may not even notice. So I'm gonna do it like this, and then this goes there, and this goes here. Yeah, and that one will just that one will just go through a via. to the power layer. Okay, this is connected. This one can be I don't want to place the via on the pad because that would require special manufacturing technique that will plug the vias, and that's about twice as expensive at least. We don't need plugged vias. This one can go there. Oh, actually, no. This one goes like this. Let's make this a bit larger via. That one didn't fit. Okay. Yeah. For routing, it's better to use 0.1 on the grid. Then it can fit there. So, like that. Actually, no. I'm gonna do it like this. Alright. And actually, I will do. Let's see, is this the capacitor? Or is this the capacitor? This one is the bypass capacitor. So this is wrong. This needs to go. Actually, yes. So this doesn't need to be a large via. This can be a normal via, but this will need to be a large via. Because this is power and this is just a signal. And the ground, can have some space here. And the ground. Nope. Like that. And this one can go directly to the ground. This one is Encoder VDD 5 volts, and is this? Yeah, this is the Norfleet resistor. Yeah. And then we have this connection going all the way there. Okay. I'm gonna leave that connection for now. That's gonna be a power layer connection. I can route all the power layer connections. Let's see, no, this is actually going to be going to the power layer as well. I'll route all the power layer connections in one go later, or if I discover that I should probably do it. At the moment, it's kind of better to leave it as it is. And just continue routing on the signal layers. This one goes to 5 volts, and this one is for the, let's see, what is this? This is a bunch of Norfleet resistors. Actually, why do I have them there? That's so impractical. I'm going to change the grid to 0.25 for placement, and I'll just move them together because this is not necessary. It's gonna be, let's see, Maybe they'll even just fit on the same. Come on. Okay. Yeah, so they fit nicely there, and this one can be connected directly to a via there instead of going as it was before. I'll remove this track and connect the via, and this one, and this one. This doesn't have to be done like this. Sometimes I just drag the trace through all of them. And in this case it doesn't really matter because this is not a high current connection. But if this was power connection, then it would be a good idea to have separate vias, because that adds more copper thickness for that particular path. So this one goes there, and for routing I'll use 0.1, and this one goes there. Okay. Excellent. Do I have any? Yeah, I have a few designators that have been hiding behind components. Come on, stop hiding. And this one is hiding there. Okay. And I have this one. Go there. All right. So then these power connections go to one each. One goes there, the other one goes there. And I have them implemented here as a copper fill. Let's see, should I just use the front or just the back? It's not really necessary to have two layers there. It's just a waste. Let's have a look. Yeah, not even the front and the back, but rather the power layer. It's much better. And I'll delete. Or actually, I'll not delete that one. I'll just move it to the other side here. Let's see. And the vias, I can also remove the vias there. Let's see. These ones are not necessary either. I hope I'm only deleting the vias. Yeah. Sometimes with KiCad you never know. Like, it can select things on different layers, even though they're hidden. Okay. Looking good. And then, what? Did I just delete that one? Or is it? No. I just deleted that one. Because I got into the habit of using Shift Select, because I have to do it here in order not to select the outline. And it goes around here. So if I just click like that, I select the outline. So I use Shift Select. And unfortunately, that sometimes means that I have something else selected, which I inadvertently delete. Let's see. this goes here. I'm going to place it slightly above the center of the holes so that it gets filled. And I also have to update the net which it is connected to. So it's going to be Inc to VDD 5 volts, and it should work now. Yeah, there we go. Yeah, I think this is a good way to connect the power actually. So this is what the power layer currently looks like. I think there will be some connections here also. It's good to take them into account because it would be nice not to have to change layers to make everything connect. Okay, and next would be what else can I do here? I got the debug connector, I got the LCD connector, and the UX connector. Let's look in 3D viewer and see. This is what the board looks like right now. And this is nice actually because the flat cable can go outside the board. So if there is anything on the top of the board, it would be nice to have the flat cable closer to the edge, so it can just go out. And for the debug connector, it doesn't really matter because when debugging the board, you're not going to have anything above the board anyway. Let's see. So this should be fine. And on the bottom layer, I have let's see, what was this like? Yeah, let's just rotate it like this. There was this shortcut which I forgot. Was it like F2? F3? No? Shift. Oh, yeah, X and Y. Okay. Back view. Bottom view. Nice. Okay, so mostly the overvoltage protection / ESD protection, but let's see what happened there. Why is that resistor missing? Yeah, and then the power and the amplifier for the voltage sensing there, and then the LEDs. Or actually, no, this is the LEDs, and this is for the Ethernet. So kind of trying to keep the number of components on the back to a minimum, but making the best use of the back layer to avoid overcrowding the front layer. Okay. Top view. And I should probably move that switch slightly away from the plastic connector. Let's do that. So I'm going to check the capacitor that was missing, which was over there. So that would actually be here. Is it that one? It's a resistor, so it will be that one, R7. Be that one. that connects to that one. Yeah, I think that would be a good idea actually. So we move R7, flip it around, and then do it like this. And route this one on the back layer as well, just like all the others. So, like that. Then, like this. And this one goes straight to there. So one of the nice things about having a border that is created using footprint and not just fills is that I cannot actually route anything on either the front or the back layer across this border, which is very nice. Even when I drag things around, I can be sure that nothing will cross that border. I'm just going to make the track thicker. Okay. 482 unconnected nets. This will go here. And HAL C goes here. And then ground. See. Where does this go? Okay, this one is there. And on the ground of the EPROM. Actually, the EPROM, do we need to have the EPROM here? Yeah, it's probably a good idea. Have the I2C bus right next to it. So connecting all the ground pins. 460 unconnected nets. And I basically have to live with the fact that a lot of the traces here will intersect because I have no other way to map the pins. I'm really try to. So it's actually, I'm very lucky that every single pin that I have to map, I was able to map with this package. Otherwise, I would have to have a bigger package. This one seems to be perfect for this application. So, more ground pins. And I'm not going to have any, let's see, let me just check this. This is, what? Right, this one is, yeah, this is 2 resistors. And I'm not going to have any fill on the top layer that goes to ground, because I don't see any reason to do that. That would just create a lot of loops in the ground and make signals go all over the place. And I wouldn't have any control of where the signal is actually going. So I would have to, if I have a ground plane on the top, I would have to stitch it everywhere with bias. So I might as well just do it like this. There is no reason really to have a ground plane on the top, unless it's for either things like this or shielding of particular traces. But then I could just have just a guard trace that goes to ground. So ground plane is going to be only on the inner layer. This one can go there. This one can go, let's see, what is this? So actually this one can go, it all kind of depends, yeah. This one can go on the other side, because this one belongs here. And then VDD3v3 is supposed to be on pin 17, right? So the bypass capacitor is there. And these ones are just connected to VDD3v3, they don't need any bypass capacitors. Yeah, these traces I'll leave for now, because I need to route everything else. And actually, I'm starting to feel like maybe I have too little space here to actually route all of this out. Maybe it would be a good idea to actually place these resistors on the back. Let's see, here we have just a few resistors. And the boot one. Yeah, the boot one should definitely go on the back. It's absolutely unnecessary to waste space here. And it's quite possible actually that I would have to move this anyway. So if I only hide the layers like that and just move this one a little bit out. Something like this perhaps. Because there's a lot of connections going there. Is this, what is this? This is the V-cap, okay. Yeah, the V-cap can go on the back as well, because there's going to be a lot of connections there. So the V-cap goes there. And then, footprints on the back. Oh, yeah, I didn't see that one because I had it hidden. So I already had one VCAP on the back, so might as well have both of them on the back. Like that. We have the CAN bus, which goes there. Right. So what I'm gonna do now, I wanna lay out as many of the analog traces as possible before I move on. And I think in the current state of this untanglement of this mess here, I think there's very little we can do besides what I've already done. So it's probably a good idea to start laying out the analog traces. Okay, so first of all, there is the current sensing, which has to go, which is critical. So this one is absolutely critical. And it's quite likely I'm going to have to actually trace all of the control signals on the back. So if I'm placing the analog signals on the front, it kind of makes sense to put all the digital signals on the back. Let's see. Or maybe actually I should make it the other way around. No, it's better to have the analog signal at the top. It's closer to ground. Although in this case it probably doesn't matter. There is a very good application note from TI that explains the problems, the most common problems when laying out an analog board. And one of the things is that you actually lose like 4 least significance bits on if you have a 16-bit ADC, or I think maybe it was 12-bit, either 12 or 16-bit. You actually lose several least significant bits per inch of trace. So this is like 2 inches, I think. So coming from here, roughly, yeah, roughly 1.5 inches, plus the distance here. So yeah, probably 2 inches if I take the full length. And so the several bits of the precision are lost because of the trace length. It's really important to keep the traces as short as possible. Of course, sometimes it's not possible to keep them short. Okay, that's good. And then this one goes here, and this one goes there. Damn it. Okay, so anything that goes out of here will have to go on the back. So then I'll have to move this one here. Okay. And could it actually make sense to place these ones? Yeah, I think I'll do that. I think that placing them on the back of the PCB is probably a better idea. Let's see. And I can just place a wire here, straight through. And this one there, and this one goes to the ground. Okay. And then this one, yeah, that will be perfect. So now I have only the current sensing here, and all the others will have to go on the back. So anything that goes then to the, let's see, right, so it's voltage sensing and the brake. These ones are analog actually as well. So the only one is the brake, and the analog signals will have to go. It would actually make sense or would it? I'm just thinking if I were to swap the swap some of the pins there. I'm gonna check my notes on which ADCs the pins are connected to, which is here. Come on, I zoomed out too much. Right, so I have, in that case I would have to swap probably one of the voltage sensing for the second one, and swap them to current sensing, which is fine actually, because both are connected to ADC 1 and 2, and I can program the sequence in which the channels are being sampled, so it doesn't really matter if I place current somewhere here and yeah, and phase sensing somewhere else, like here. So I can actually swap the, let's do it like this actually. This is actually very good. So I have this one, which will go, this is a control signal, and then we have the voltage sensing number 1. Do they need to cross? No, they don't actually need to cross. So all I have to do is actually just, I'm just gonna swap, probably gonna have to swap several of them here to make sure that they still don't intersect. But to start with, I'll swap voltage sensing B2 and current sensing A2. Current sensing A2 is there, and voltage sensing B2 is here. So this will go here. And this will go here. And let's also update the note here. I just want to double check if I swap the correct ones. Let's do it like this. So I2 and SB2, yeah, this was correct. So now I can connect the current here without any intersections. And then I'll just update here. Okay. And I have two digital signals, and I have the voltage sensing here, which will have to go, yeah, right. So I have to also swap then this one and yeah, the C and the B. VSC2 and VSB2. VSC2 and VSB2. So I got to be very, very careful now when doing such changes, because it's very easy to mess something up, and unless I check every single step of the way, like here I can see VSB2 has been reassigned here, and this one has been reassigned there. Unless I really check every single step of the way, I could end up with problems that would go unnoticed into production, which is not good. Alright, let's connect now the current here, current signal. These are insanely long analog traces, going by things that are digital. Although here we just have potentiometers, but still. Let's see. I wonder if Keycut allows setting minimum distance between traces through some kind of net class or something. So I could adjust the distance to be slightly larger. Like that. Okay, what other analog signals do we have here? We have overcurrent adjustment. Okay, would it be better if actually I can actually do like this. Take the shortest path possible. And it's quite possible I may need to move something around here. And we have this one. Okay, this works out pretty well. So keeping the analog traces on the same layer without any intersections. without having to place any bias along the way. And next there is a lot of sensing, so voltage sensing here, for example. This needs to go there. And then this one. No intersections there so far. No. Come on. Get. Yeah. And next we have digital. Everything is digital. Until we get to could be one of these maybe. The offset and the input. Where does this go? I can't see anything that's highlighted. ESA to raw. It's interesting, is that not even connected anywhere? Alright, yeah, this goes to the resistor divider and then to the motor. Okay. So what about any of the other sensing? So this is the inputs and TP84. This one. Alright, this one needs to go there. That's not going to be doable without any intersections. So 94, yeah, and that's 84 is the last one. Okay, could I perhaps reassign them somewhere here? I don't have any other pins here that are analog. Or do I? Or do I have anything that's even reassignable here? So it's not non-reassignable, no, no, what's this? No, 40, no, not an analog, no, yeah, and these ones are not analog pins. about the VS? Right, so the voltage sensing here will go to these pins. That's also kind of not perfect. Really, placing this on the other side there is not an option. So this will have to go on the bottom layer. But I think I'll just do it like this. Okay, this one is not necessary. This is incredibly long analog traces. And I'm finding that at this point it's not really possible to optimize it more. It has to be, this is like the best placement, considering everything, all parts of the PCB. So this will have to do. And I have 3 of them coming out there. Let's see. So what I'll do here is just move this section. It's nice to have the reset button by the programming interface. And then I'll just move this, and I'll just trace the voltage sensing connections out here. And then the third one, just because I want to see where they connect and how to best connect all of them. So I just trace them out a bit closer, and then I can see where they connect. For example, these two intersect. So even here it's good to just rewire the sensing. However, I still need to have vias anyway, so I could actually just cross them as I do the via and the trace that goes underneath there. So this will go there, and this will do a little crossing there. Let's put this one in place first. All right. And then I have this last voltage sensing, the last voltage sensing input, which has to go here. I can't do that actually because I have a lot of traces that go there. I'll have to route them somehow, so I have to keep enough space there. Instead, I'll have to go behind the capacitors here. I could actually come out here. I can just go and follow the same. Oh, come on. And then I'll just follow the same route as the other ones. Alright. Insanely long analog traces. I don't really like that. But this will have to do. Also, for the voltage sensing, it doesn't have to be exact. It's more important to have the current sensing. Current sensing really needs to be perfect. But voltage sensing is not that perfect because we're only interested in the zero crossings. So it's kind of it's an estimation either way. So we're not basing anything on the precise value of it. Now, so I got 3 connections there, 3 connections there. That's overcurrent threshold and current and voltage. Do I have anything else here? I think that's pretty much it. And then I only have the ADC3 left, which has the VMOT temperature and joysticks. So the temperature goes here. This will be the temperature sensing. It's located, I've placed it kind of by the side and close to this large copper area. I think that's the best place for it. I can't really place it anywhere else. Doesn't make much sense. I think if there's anything that's going to get hot, it's going to be centered around this place here, because we have the high current path, and this path is actually more high current than each individual motor, because this goes to both motors. I had a few traces there alongside of the copper fill. I'll just delete them. They're not necessary. So I got one of the sensors there, another one is here. Yeah, that's good. And then this signal will go to the input here. Perfect. Oh, wait. No, that's wrong. Of course. That's totally wrong. That's actually the power. That's the 3v3. So that will go to a via, and then through the power layer it will be connected to the 3v3. And this is the signal. So I need to actually route this one. Let's move this one to the other side. This one. That's better. This is the signal that needs to go. Okay. Right, I see. Let's place them here. Actually, I'm going to place it here. Primarily because I don't want to disturb the copper fills here that connect. I want to keep this disturbance as little as possible. So I'm going to just have the trace going there on the side of the copper fill, and then it will go over here. And then it should go over there. That's insane. The filtering capacitor, I can place it here. And flip it around. And then this one will also be removed. And then I can just go here. Yeah. I'll just try to follow the same path. Can move them in place later. So going around here, and then I need to go. Yeah, I could actually do like that. So if I were to go underneath that, let's see here. So I have to switch layer and then go here. I have to go all the way there. Which is a bit annoying. Should I have actually put the analog traces on the back instead to keep them away from all the components? This will have to do. Okay, I'm gonna just move this slightly to the side here. And change the grid. this one's stuck somehow, somewhere. Why am I not able to move it? There we go. Now I should be able to trace this one. Okay. The wire wouldn't fit. Somebody who is an expert in analog design should probably comment on this video and tell me if this is a good idea. Actually, tell me potential problems with this design of the analog connections. I have to go underneath there. There is no other solution here. Yeah. Okay, so that would be the analog signals. And the next step is probably to actually route the motor control signals. Try to clean up as much as possible here. So then I'll use the back layer predominantly for the motor control signals. And they'll go like this. Let's make it a bit thinner. I'll use that trace. Okay. And this unfortunately has to go on the back there. Let's see. Okay, so it doesn't have to be actually. It doesn't have to be precisely like non-inverted and inverted. As long as we keep the pattern consistent, we can actually remap the inverted and non-inverted. Then we have also these signals, like gain, what else? We have that one. And these ones cannot be remapped. This is the only way to map them on this package. So I have to go here. Okay. This is going to be tricky. I have to move this one closer there, so I have a bit more space for the bias. And I'll go with this one. See where this one goes. So this one needs to go there. Oh, that's perfect. That is actually perfect. This one, let's start with just following the same path, and then we'll see what we need to do. Okay. This one's a bit more tricky. So, what if I move this? Let's see. I can move this one closer, actually, here. Can I? Does that screw something up? Ground. Okay. What is this? This is the Hall sensors. Gotta keep these traces away from the VREF. That's the only thing. This is HAL, so that's fine. Can I move it a bit closer? Why is it not working? Is it because I have a wire there? That seems to be the case. There we go. That's a bit better. And then this one can go here. Damn it. Come on. And I have to let the mouse go when the cursor is in the middle of the via, because otherwise, unless it can place the via somewhere where I'm pointing, it's just going to return it to where it was before. So, now we have this one. Ooh. Okay. Yeah, we can actually go like this. This is fine. We just come out there and then just go back a little bit. Come on, this is ridiculous. I don't want it to go there. I want it to go here. click, yep. And then, oh crap. Okay. This is why I don't like having this functionality enabled when I'm laying out a track, because it's so easy that it will mess something up and I won't even see it. Okay, so this one goes there and then just there. That's fine. So, okay. Let's do like this. Okay. And this and of course it messed this one up. Of course it did. Of course it did. There we go. And then I guess we have the last one here. Oh fuck it. I'm not gonna. So, this one goes here. And also just comes out here. And then in here. Perfect. So considering that we have to use the device anyway, might as well just use them. Why does it have to mess it up like that? Incredible. Okay, let's track this one. Nope, that didn't work. Did this get messed up? Oh, it has the via there, of course. And when it has the via there, it's not going to move that easily. Okay, conserving space. Crosstalk is not an issue. And all of a sudden I cannot move it closer than that. Do I have to have grid set to the minimum? No, I still can't move it. Well, now I could. But then it jumped back again. Oh, there we go. So, back to grid 0.1. And now I have, let's see, this one, 3 to 3 MCU. That will go here. Let's make this 25. $421 unconnected tracks. Okay. And then there is all of these ones. So they can. There are a few that go here, like this one. So what would be a good place for that one? One annoying thing here is that I can't route it on the back because of this one. I'll have to move that one. But could I? Oh, actually no. I have to go on the back. Yeah. It's a bit unfortunate to place the current sensing right next to this. Maybe I can go on the back here. Maybe this would be better. Yeah, this one is actually, this is better. So I can go on the back there, and then I can go back here and just, oh fuck. Forgot to change the trace width. So I can go back here and then just trace it here. It would have been awesome. Okay. Trying to keep the number of vias to a minimum. I could actually go here. And all I have to do now is just to move this via a little bit. So that I can just, yeah, that's good. And then I'll just go, that's still very long, and that's coming right next to this temperature. Yeah, okay, temperature sensing, no big deal. That can be, that's fine, not an issue. Okay. Next is the this one. And then we have this one, which goes there. I'm gonna have to move them in place after I'm done with this. Because I'm still not sure exactly how they intersect. Let's see. Oh, this one needs to go there, okay. Can I go behind there? Okay, that's good. And then next, and this one kind of needs to come out in between the other two. I'm gonna make sure that this one stays there, and I think it needs to come out there. So if I just move this one a little bit, I can actually bring it out in between there. So I can go this way. And then I'll go here. This should land it precisely where it should be. Great. The only problem is that, yeah, that's not this. Okay. And now I can move it. jump. Did it mess it up here? Yeah, not really. Except for this one. It's so bad at actually keeping things in place while it does its optimizations. So annoying. It's like, why does it have to try to make it go that way when it can just be close to this pin here, close to this trace here? Yeah, it went. Okay, I'll keep it that way. And next we have 3 more. So we have this one, and this needs to go there. So yeah, let's do the untangling. Let's see. A, B, C. So in H, A needs to go. Oh, this is the next one, so this is easy. This goes the same way. No! Stop it. Damn it. What is it trying to do? There we go. This one goes, actually just bring it the same way. This one needs to go up there. This one can go here, and then there. And then I have this one left, which goes nicely there. So that's it. That's it for this interface, and maybe even this video. I think the video is starting to get pretty long. So this is also everything for this video. So I'm gradually untangling this rat's nest around the MCU, and now I have the most important things in place, and I'll just continue and route the debug connector, the encoder interfaces, and the SPI connections that go to the peripherals. And for example, here I will need to also add resistors for protection of this SPI bus, because I have I think I have both meso pins connected together, which shouldn't be the case. So I'll just continue routing this, and if there is anything interesting, I'll record it on the video. Thanks for watching. Bye.